Hello class, welcome to our lesson today dealing with the Pythagorean theorem. This is section 14.3 in your textbook, so you have to kind of flip further back into your textbook to make sure that you're finding the correct questions. We're going to talk about what the Pythagorean theorem is, how to solve some things with that. You want to make sure you have a calculator off to the side somewhere so that you can make sure you're plugging numbers in correctly. The first thing that we're going to look at is dealing with square rooting and squaring. Remember, a square root you can find by figuring out what number times itself equals that answer. So the square root of 121 is 11 because 11 times 11 is 121. And then I add 2 to it, so it's just 13 because 11 plus the 2 is 13. This next one is negative of the square root of 25. So I just do the square root of 25, which is 5, because 5 times 5 is 25, and I'm working backwards. And then make it negative, so that'd be negative 5 plus 13, and that's a positive 8. Notice here this has the square root of 15 squared. Now you can go through and square 15, which would be 225, and then you say to yourself, well, what number times itself equals 225, and square root it? Well, the interesting thing here is that squaring and square rooting are opposites, or excuse me, inverse operations of each other. So this would just be 15. Squaring and square rooting undo each other, kind of like add, subtract, and multiply and divide do. And then that's 15 minus 1 would be 14. This next one here is the same idea, just kind of flip-flops. So it's taking the square root of 28, which is not a good number. Okay, it's irrational. It can't be written as a fraction. But then you're going to square it. Well, square rooting and squaring is just, they're inverses, so they cancel each other out, and that's 28. One other side note, I circled this 5 to the 0 power. 5 to the 0 power is actually 1. Anything to the 0 power is 1. Just make a note of that off to the side somewhere. And so 28 plus 1 would be 29. In a right triangle, what we're going to be looking at is the angle that's a right angle. The side opposite of that, okay, kind of facing it, kind of pointing towards it, is what's known as the C, or the hypotenuse, which is the side opposite the right angle. The two legs are called A and B in a right triangle. It's important to note that it doesn't matter which one's A and which one's B. Both of those two legs are going to be smaller than the hypotenuse at all times for a right triangle. When you're making a right triangle and labeling the side lengths, you can choose which one's A and B by the two sides that form the right angle, but angle C needs to be opposite and known as the hypotenuse of the right triangle. So the Pythagorean theorem says if you have a right triangle, then the sums of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So it's A squared plus B squared equals C squared. The most common mistake on these questions is people say, oh, I don't need the squares, so it's just A plus B equals C. If that were the case, first off, we would have said that was the formula. The second thing is squaring is the inverse of square rooting, but notice there's an addition of A squared plus B squared, which makes it a lot more complicated to get rid of. You'll deal more with solving things like that when there's more unknowns later on in your different math classes. But for now, let's go ahead and start using the Pythagorean theorem. In this triangle, I'm labeling A, B, and C, but it doesn't matter which one's A and which one's B. So I said A was 5, so this is 5 squared plus 12 squared, A squared plus B squared equals C squared. 5 squared is 25, 12 squared is 144. I add those two things together and I get 169 equals C squared. To find C, I have to get rid of squaring by square rooting. So I take the square root of 169. Now, some of these you're going to know. Here's my suggestion for your assignment today. Any question that starts out as a whole number, try going through those questions without your calculator. It's good practice to get some of these squared numbers into our heads a little bit better. They should work out decently. And then our rule of thumb will be any decimal question you can use your calculator on. I think that's a good compromise, so let's make sure that our work looks similar to this. My anticipation is you probably need some ways to show the multiplication off to the side somewhere to say that the square root of 169 is in fact 13, because 13 times 13 is 169. So C, the hypotenuse, is 13. Notice that C, the hypotenuse, is larger than the two legs, at 5 and 12, and then 13 for the hypotenuse. The next question, again, you can pick which one's A and which one's B. I chose to make 15A and 8b, so 15 squared plus 8 squared equals c squared. I'm going to write that down. Your work should look similar to this. 15 squared is 225, 8 squared is 64. I add those two numbers together and get 289. And then my goal is to say what number times itself is 289. An important thing that might help you in these scenarios is using estimation to kind of get into the right track. First off, we know this is less than 20 because 20 times 20 is 400. We also know that the number ends in a 9. So think about what numbers multiply to equal 9. Well, 3 times 3 equals 9, and 7 times 7 equals 49, which if I was multiplying puts a 9 in the ones place. So there's really only one option here, and it has to be 17 if it's a good answer. And I would never ask you to show that unless it was a nice answer. If it was an answer that didn't work very well, we would plug it into our calculator to find the square root of. The next question you'll notice is solve for b. This question is a little bit different, but I'm still plugging in everything to the same locations. A is 16, so 16 squared, plus b squared, which is unknown this time, equals the hypotenuse, which is known to be 34, and square it. Take 16 squared, that's 256. Take 34 squared, that's 1156. But this is like a two-step equation now. I need to get rid of the 256 to get b squared by itself. So I'm going to subtract 256 from both sides. When I do that, I'll get b squared equals 900. I find the square root of 900, what number times itself equals 900, and that would end up being 30. I would like your work to look like this. Okay, so your work should look in a similar fashion to what this is shown here. Your teacher will be looking for that as we move forward in this lesson. The next question is a little bit different, but the triangle is just rotated. So I've got a squared, which is unknown, plus the other side length that makes the right angle is b squared, so that's 2.1 squared, equals the hypotenuse across from the right angle, 2.9. Square 2.1, you get 4.41. Square 2.9, you get 8.41. I still need to get a by itself, so I'm going to subtract the 4.41 on both sides. That leaves me with a squared equals 4, and square root that, and you should get 2. If it's a decimal question like this, feel free to use your calculator more. But I'd like you to try these other questions without your calculator. Again, the reasoning is you need to start knowing these squared numbers like these first 3 questions or so. So let's try those whole number questions without our calculator as we move forward. The next question has some fractions involved, but really it's not too bad. First thing that you want to make sure of is, yes, you can make things a decimal. So if you get yourself stuck and make things decimals and do Pythagorean theorem, that would be fine. But most questions that are designed as fractions are meant to be done as fractions. So 2/5 squared plus 3/10 squared, because those make the right angle, those are a and b, equals c squared. When I square a fraction, I just square the top and bottom. So 2 times 2 is 4, 5 times 5 is 25, 3 times 3 is 9, 10 times 10 is 100. When I add fractions, I have to find a common denominator. So I'm going to multiply the first fraction by 4 over 4 to make it out of 100, and it's 16 out of 100. When I add fractions, remember I just add the numerators, so 16 plus 9 is 25 out of the 100. That simplifies down to 1/4. Then it still finds c by taking the square root. So I take the square root of 1/4. One of the important properties of square rooting is in a fraction you can just split it up, kind of like a distributive property type situation. Okay, or so 1 square rooted is 1, and 4 square rooted is 2. So c would equal 1/2. A good quick check to at least see if we were on the right track is my hypotenuse larger than the 2 side lengths, or the legs? So 2/5 is about 0.4, 3/10 is 0.3, and 1/2 is 0.5, so it's definitely the largest side. If a question starts as a fraction, try to attempt it as a fraction to start with. If you get really stuck, then you could try the decimal. Okay, your homework today is section 14.3, numbers 3 through 11, and 19 through 23. You need to make sure you show the setup and steps on each question. That's what we're looking for your work. Your work should look similar to all of these different slides. Please make sure you write the Pythagorean theorem down, a squared plus b squared equals c squared, and then plug the numbers in for a, b, and c. From there, you'll need to multiply things by itself, add things together if you're solving for c. You'll have to subtract things out if you're solving for a or b, like this question here, and then work backwards to try to solve for the missing variable. Remember, you're trying to take the square root of things, so you have to think what number squared equals that answer. Have a good day, everyone.